because these zones have different characteristics. So we tried to characterize them in different ways. You can just about see. So inertia. So what's this is like the percentage of the total system inertia that they have, just the number of buses. So how big is that region? The average node degree, it's like a graph metric. So how connected is it? So if this is basically tells you the average number of other nodes that each node is connected to. Okay, so it's usually somewhere between like 2 and 3 in most networks anyway. But this one is here. Average line loading. So how overloaded are my lines, or how close to overloaded are my lines? So these numbers are going from like 0 to 60. And then this is G over D. So this is generation over demand. So essentially, is this region a kind of net exporter of energy, or is it a net importer? And so here we're just a little bit over 100. So that means it's just going to be slightly exporting. Okay. And we do this for all those different regions. So these different regions have different properties. So you can see here, this one's probably the highest inertia. This one's like the lowest inertia, or maybe this one. This one's really quite low inertia and quite heavily loaded already. So these lines are already up to over 50%. This one over here, zone 6, very low loading on the lines to start with. They're down about 20% loaded. So there's loads of extra capacity on these lines. So we kind of looked at these different properties and we're like, okay, let's see if this has an effect.